Hello, this is Siksha Vinay, and I'm going to teach you about kinematics for standard 9. Today, this lecture is all about relative motion. How you use relative motion in kinematics. It is very important topic for understanding of physics. I've already told you what do you mean by relative motion, that you have to measure something or motion with respect to somebody or with respect to some observer or reference frame. That is called relative motion. And I have already dealt you that what do you mean by relative and the word absolute. Relative word means you have to measure something with respect to something, but absolute means you have to measure something without any reference. So here I am going to deal what do you mean by relative velocity, relative acceleration, relative displacement in the motion. So first of all, I give you some situation. All of you must travel from train with the train, and if you have observed that sometimes your train is actually standing on the platform, but it appears moving when you see other train in front of you. Yes or not? Why this happens? Because actually other train is moving, your train is standing there, but why it appears that it is in motion? I have already said that everything is relative in motion. So yes, your train is not moving with respect to embankment or platform, and the second train is moving with respect to ground, as a man on the platform can see clearly that your train is not moving there, and another train is moving, but you cannot say the same thing because you are in the train. So your reference frame is train, not embankment. And when you see other train, then your reference frame becomes the other train. Have you got my point? So in respect to that you can perceive that your train is moving. If the second train is moving in north direction, you will feel that your train is moving in south direction, because your mind then perceive the motion of your train with respect to that train. So it all depends on reference frame, where you are and where your reference frame, what is your reference. So how can you find out the velocity or magnitude of velocity in this case? If let's say that your train is standing there and the another train is moving with 5 meters per second in the north direction, what you perceive? In which direction your train is moving, that you feel, or by what magnitude it is moving? Actually you can say the same, your train, you have to feel that your train is moving with the same speed but in the opposite direction as actually the second train is moving with respect to embankment. Have you got my point? Now I give you another example. If you are in a bus and you are watching from window and you are watching the road, actually the man on the road is not moving, but the bus is moving. But for you, bus is not moving, road is moving in the opposite direction. Yes or not? So this is the case I am discussing here about, and I'm also deal about how to calculate the magnitude of some object in motion with respect to another object. So what do you mean by velocity here? Let's say your friend A is moving with 2 meters per second eastward, and you are moving with 3 meters per second in the same direction along the same line. So what is the velocity of your friend with respect to you? What do you mean by that? Means what the velocity of A when observed by B. If a man is standing there, or your another friend is standing here, he always perceives that the boy A is moving towards it by 2 meter per second and the B is moving with 3 meter per second. If I say that your speed is 2 meter per second, we generally take reference frame as ground. So this is actually 2 meter per second with respect to ground, and this is nothing but 3 meter per second with respect to ground. But what happened when your reference frame is changed, when the reference frame of A is B and the reference frame of B is A, not the ground? Means your friend is watching you only and forget about your surrounding, and you are watching your friend only, forget about surrounding. In this case, you must feel that your friend has lesser velocity, and your friend must see that you have also lesser velocity. What B sees, that A is moving in the opposite direction with the lesser speed, let's say 1 meter per second, but A perceive that B is moving with eastward direction with the velocity of 1 meter per second. How can you say that? So what do you mean by with respect to, if you take any reference frame, treat it as that it has no velocity at all, or you can treat it as that it is at rest. Have you got my point? So now if you take A as reference, then its velocity, ultimately you have to choose that its velocity is 0. Likewise, that if you take ground as reference frame, then the ground is you take ground is as at rest, but ground is not at rest because it is moving with the speed of earth. But in your case, in your perceiving, in your practical case, you can treat it as 0. Yes or not? In the same way, we can treat it, if we take reference from as A, we can treat 2 meter per second as 0. So how can you say what is the speed of B then? It is 1, because 1 meter is ahead by 2. That means it is going eastward direction, as it is moving in the original case. You also perceive that it is. But when B sees you, that it perceive that A is moving with 1 meter per second in the westward. So what I have actually conveyed to you, that if you take B as a reference frame and then you can check the velocity of A, that means it becomes VA minus VB. Have you got my point? And if you take the reference frame or observer as A, then the velocity of B is VBA, or you can write VB minus BA. Actually we have to subtract in the relative perceiving. Have you got my point? So now you can find the answer for that. If the two train is moving with A is moving with 2 meter per second and B is moving with let's say B is moving, let's say, in the opposite direction with 3 meter per second, and one boy is here and one boy is here. What we perceive means, what is the velocity of A with respect to B? How can you find out? So it is easy, that we have to know that velocity of A with respect to B is, you have to minus the velocity of B in velocity of A, because we treat BB as 0. Have you got my point? So VA is 2 plus 2 because we are taking eastward direction as positive and westward as negative, because this is velocity, not a scalar quantity, it is a vector quantity, so you have to take plus and minus with that. So and now minus VB is in the west direction, so you have to take minus 3. It means plus 5, means means we must see that A is moving with 5 meter per second in the eastward. Now in the case of this VB minus VA, VB is minus 3 and minus VA is plus 2, that means minus 5 meter per second. Automatically A also sees the boy moving with same speed but actually in the opposite direction. Means in the relative case, both the person can see the speed as magnitude of a speed is same but can see in the opposite direction. Have you got my point? So I give you general expression for relative velocity, that BAB is VA minus BB. BAB means you have to take observer as B, BCA, and here AC is B. So here, so what I have told you that relative motion means if you have to take a reference frame, then you have to treat its velocity as 0. Means if it has VA velocity with respect to ground and if it has VB velocity with respect to ground, so in relative case you have to in this case B is reference frame, so you have to take it at rest. How can you take it at rest? You have to subtract this velocity in this, so you have to subtract here this velocity with respect to ground VB, so you have to subtract VB. So if you subtract VB in this case, you have to also subtract VB in this case, so you have to VB minus VB. Have you got my point? So whatever reference you have to convert it into 0, because you have to perceive the motion of any object with respect to that reference frame. So if I subtract VB into this to convert 0, I also have to subtract VB in that speed also. Have you got my point? So this is the actual meaning of the relative speed or relative acceleration or relative displacement. So I give you some example, you have to solve it so that you can understand about it. So here if B sees A, that means its velocity must be plus 2 and minus 7. I has already told you that minus indicates the direction, so and plus also direction indication, so it becomes plus 9, means 9 meter per second towards east. Have you got my point? Now in this case, if A is observer, A perceive the motion of B, then you can write it minus 7 minus plus 2, it gives minus 9, as we have we can thought it, because it is 9, it is also 9, but the direction is here plus, direction is here minus. So in every case magnitude must be same but direction is opposite. So now how can you solve the problem? I am giving you some problem so that you can be skillful in that matter. So now here a body moves with 4 meter per second constant velocity, and B also moves with 8 meter per second with constant velocity in eastward direction. But B starts after 10 seconds to catch A. It is like a police thief problem or car racing problem to overtake some car. This kind of problem is like this. So B starts after 10 seconds from A. So at what time B can B catch A or not, we have to discuss, and the distance traversed by the B during the motion to catch A. How can you find? So I have to take the concept of relative speed or velocity or motion, acceleration, like that. So B is catching A here. So B is police in this case, and A is thief. A is criminal. So we have to find the speed of B with respect to A, because we have to treat A as at rest, because I have to catch A. So the speed of B becomes VB minus VA, 8 minus 4, which is 4 meter per second. Have you got my point? But it is actually 4 meter per second just after 10 seconds, because B is not moving before 10 seconds, and before in 10 seconds A is moving and covered some distance. Have you got my point? So we can say that the relative displacement between A and B must be initial relative displacement or relative displacement which have to covered, it must be SBA. So in 10 seconds A is covered 40 meter, so displacement must be 40 meter, relative displacement between police and thief. Have you got my point? So the police must have to cover 40 meter relative displacement by its relative initial velocity, as I have already told you that by its relative velocity 4 meter per second. So here relative velocity is 4 meter per second, displacement is 40 meters. Treat it as normal velocity and displacement. So here speed is constant, that's why time becomes distance by speed, so it becomes 10 seconds. Means here the answer is same, that 10 seconds, but here after 10 seconds after just starting the motion of B catches A after 10 seconds, means A is in motion by 20 seconds. Have you got my point? B only left 10 seconds, but A had left 20 seconds, because A has started 10 seconds before than B. So we have calculated time to catching A, and now you can find the distance covered by B is speed in time, because the speed is here, speed of B is constant. So here the speed is 8 into 10 means 80 meter is covered by B from the starting point. But the time taken by B is 10 seconds only, and the time to catch at the point of catching is 20 seconds for A. Have you got my point? So this is the case, a police thief case, when velocity or speed is constant for both of them. But what happened when one has acceleration and another has constant speed? So this is one of them is accelerated. So I give you situation that the police thief has constant speed 4 meter per second in the same direction, and the police is moving with initial speed 0.5 meter per second, but it increases its speed by 2 meter per second, 2 meter per second square. That means it is accelerated, its acceleration is 2 meter per second square. But here also the B starts after 10 seconds. Means police has started its jeep and then want to catch the thief after 10 seconds. So in the same way we can find out relative displacement relative displacement is after 10 seconds B starts, so relative displacement, it is a constant speed 4. That means a speed into time, that means 40 meter, the relative displacement you have got. Now what is the relative initial velocity? Initial velocity is of B is 0.5 and velocity of initial or final whatever, because it is constant, 4 meter per second. That's why the relative initial velocity of police is this. I've got my point. And now relative acceleration is, acceleration of A is 0 because it is in constant motion, uniform motion, and B is 2 meter per second. That's why its acceleration is 2 meter per second. We can find relative acceleration. In the previous case, there is no acceleration for both the cases, both the person. That's why we don't have to need mention acceleration. But in this case, we have to mention acceleration. So you have to find out the relative acceleration. Now it is easy that you can apply the equation of motion for this case. Have you got my point? So using equation of motion, you can find out the time to catch the thief. So this is the equation of motion, and you can solve it by, this is somewhat approximately 4.8 seconds. So you can find out the distance covered by police is by equation ut plus rvt square. So now you have understood what I am conveying to you. So this is actually easy. You have to focus on that. You can find out, and this is so exciting also. So now I am giving you the questions for solving by yourself when both are accelerated. I am giving you situation that thief is moving with initial velocity 4 meter per second, but it is increases its speed by the rate of 1 meter per second squared. But police is moving with initial speed 2 meter per second in the same direction and with the acceleration of 9 meter per second squared. But B starts after 10 seconds. In how long it will take to overcome and catch A, or distance covered by B in the whole journey, or distance covered by A in the whole journey. You have to find out. Do it yourself, so that you can be concretize your concept. Numerical solving ability is important to grasp the meaning of what is conveyed by the topic. So I am giving you last puzzle for you. I have told you about the cases when the motion is along the same line, either in the opposite direction or along the same direction, but along the same line. But here I am giving you along two different lines. I am saying A is moving with 3 meter per second along north direction, and B is moving with 4 meter per second along the eastward direction. What happens if B was A and if A was B? It is sure that its magnitude is same and direction is opposite, but I have to find what its magnitude, relative speed. How can you find it? Think about it. Try to solve it. And if you have any problem and face some trouble, then you can contact me or comment on my YouTube channel. Thank you for watching.